network with not only some of the vendors, but also some of just mingle with all the other vendors that are here today.
We're good to go. Go ahead and you can go ahead. You can go ahead and introduce her. You can go ahead and introduce her.
So I'd like to go ahead and our next presenter come on up and perhaps get started. Again, GWen Hoheisel, regional extension specialist, is going to be presenting next.
And she's actually coming in remotely. So we, as you all probably are aware at this point, we live stream this to Prosser in southwestern Washington, and Gwen's going to actually present remotely. So Gwen, if you can hear us, go ahead and let's check the mic. I got your, I've seen your screen.
Yeah, I think I can hear myself through yours. So Chris, just let me know if I can start.
Go ahead. You're a little bit echoey, but we'll make it work.
Okay. It might be. All right. Okay, so thank you very much for letting me present from Prosser because, well, there's a whole group of growers here that are here all day. So I want to present to you on research that we did that was funded by the Oregon Blueberry Commission and done with collaboration with Vaughn and Starhawk, who's our graduate student at Oregon State University, and some graduate students from WSU. And so this is an evaluation of 3 sprayers that we use and commonly used in blueberries. And if you've heard me in my talks before, my motto is every drop to the crop. So that's our goal in spraying. And sprayers, the 3 things that have the greatest influence on any sprayer, including these 3, are droplet size, air, and weather. And I'm going to go through each one of those and show you how these sprayers will be adjusted or adapted and how it plays into getting them dropped to the crop. So, just have it once. Okay, just hit next, Mr. Arrow. So, there is no perfect machine. So, all can be operated poorly or perfectly. So, I'll put that there that even if you think, man, this machine is really recommending this, I'm not recommending a machine. And I've really seen them get screwed up. You don't want to provide good coverage. So my assumption when you're doing this is that you have maintained your sprayer properly. That includes all these things you normally do. But if you don't do these, some of the sprayers we're going to talk about can have a lot of problems. Okay. So the sprayers that we evaluated were a pack blast, a Canon sprayer, which is the second sprayer being shown, and an on target. And the pack blast you're probably the most familiar with, the small version of a rear dare blast. 5 nozzles on each side, all has smaller fans. The Canon sprayer is marketed in their words that
Gwen, can you hear me? Gwen, can you hear me? Can you please come closer to the mic? Maybe she doesn't hear me.
Yeah, I hear you.
Okay, can you just get closer to the mic? It's really echoey.
So you know what I'm going to do is I'm going to get off stage and go closer.
That's fine, for the record.
Okay, is that good? Or better? Okay, Chris, is that any better? All right, I'm just going to keep talking, and you can text me or tell me if it's not. So there are 3 unique sprayers, and That's okay. Okay, so the Canon sprayer is marketed so that,
Apologies for this. Everyone just hang tight.
hey, what's up? I'm standing right next to my microphone and right next to the receiver.
Yeah, just be careful of feedback. Gwen, can you please get closer to the mic? We're not getting anything from you at all.
Chris,
Okay.
I am standing, can you hear me right now? Chris, I'm not near a mic. The mic is a portable, like I'm not, like it's right at my mouth.
That's actually working really well. Do whatever you're doing right now.
Right now?
Yeah.
Okay. All right. Good. Okay. So the Canon sprayer is advertised as a sprayer that will, you can drive it around your block if you've planted too close or you don't want to drive through, and it will actually spray in a 100-foot swath all the way across your field. So then the last one, which is all the way on the right, the white tubes, that is an on-target electrostatic sprayer. It runs by having a weak charge on small droplets, very, very small droplets. And it's supposed, that weak charge is supposed to be attracted to the weak charge of a plant surface. So we went through, we tested these at rates that were gallons per acre that were acceptable for each machine. We did adjust for that within the data. And then we looked at each coverage that we're going to talk to you about. But that picture at the bottom with the green dye, that's a dye that fluoresces. And we spray with that and then measure it in the lab to see where and how much material went with each sprayer. Okay, so what we did is we did each sprayer. There were 6 canopy zones. And so that we had 3 going across the top of the canopy, 3 going across the bottom of the canopy. And then we had 3 rows that we measured from the spray row of aerial drift, which we took poles that were 1 foot, 2 foot, 3 foot above the canopy. And then we also measured ground deposition that were 1, 2, and 3 rows apart. So the Canon sprayer, we actually set up to spray 3 rows at a time, a 30-foot swath instead of a 100-foot swath. And so it had a spray row of 3 rows, 30 feet. And then from there, we went over 3 rows with aerial and ground drift. And the other sprayers spray 1 row at a time. Okay, so now you know what we were doing. Let's talk about those sprayers in relationship to droplet size. So droplet size, remember that nozzle type matters, and it dictates the size and whether it can be adjusted or not. And the higher the pressure on the machine, the smaller the droplet size. And so if you are not convinced that you should care about it, here's how labels, regulations, and such are coming down. We have many herbicide labels that are now listing on them the droplet size, whether this one here lists that you have to have a medium droplet size, you cannot use a coarse droplet size. There are some canopy labels, some pesticides that are used for canopies, pests and diseases that are also being considered to be regulated with canopy droplet sizes. Also in Washington, we have our new, well, in the US, we have our new worker protection standard rules. And in there, which you guys are all familiar with, there's the application exclusion zone. And within that, they have a determination that says if you're using an air blast sprayer and it has fine or very fine droplets, you have to have a 100-foot buffer. If you're using a sprayer that can produce coarse or larger droplets, you only have to have a 25-foot buffer. Unfortunately, the way the law is written, even if you put in droplets in your air blast sprayer that produce coarse or larger droplets, they're still going to restrict you to that 100-foot buffer. But that's just because they didn't understand all the regulations, and there's been a lot of questions afterwards. There is a lot of discussion about if you prepare air induction nozzles, other types of technologies that get larger droplets, less drift, could your regulations be a little less severe? Okay, so nozzle types. So now the pack blast sprayer uses the nozzles on the left, of course, that you know. So it can change, any of those, it can change into a disc core. Yeah, hopefully you're using ceramic disc core. It can use one-piece nozzles, which produce a fine, very fine droplet. And it can also use air induction nozzles, which would allow you to use a very coarse to extreme coarse nozzle. The Canon sprayer and other sprayers that are like it use air shear type technology. That droplet size can be very variable, but have a lot of fine to very fine. And the same thing with the electrostatic. It is going to be a very small droplet size on that electrostatic. And the reason being is that the smaller the droplet, the stronger the charge it can hold. So you cannot ever use the electrostatic at high gallons per acre. So 20 gallons per acre is about the max you would use it at. And you need it at a high pressure to produce small droplets, very fine droplets, so it at least holds a charge. If you do anything different than that and get bigger droplets, then you've negated the purpose of the electrostatic. Okay, so a while back, people said, hey, ASABE said, let's make this easy for people. We'll color code it so that everybody can figure out exactly which nozzles to use. So they came up with this color coding system so that if you find red, it means a very fine droplet, orange, a fine, yellow, etc., medium. But when you actually look in a catalog, it's really confusing because they have colors all over the place. It's like a preschool magazine. So the colors that are associated with the categories of the droplet size are actually the ones in the center of the table. So there's a V, C, and a C, and an M. Those are the center of the table. That is the color. On the left side, there's an orange, green, yellow, purple, blue, red bar. Those colors are absolutely arbitrary and actually line up with what the color of those one-piece nozzles or air induction nozzles are. They have absolutely nothing to do with what your droplet size is. So just be careful about that when you're selecting. If you choose to go with the pack blast, which you can change all of these nozzles, and you want to take advantage of droplet size, you're going to end up having to look at it a little carefully. Okay, so let's look at air. So the goal, if you were going to do one thing besides my very first slide, which was make sure all the parts are working correctly, matching the air to the volume of the canopy is the key to proper deposition, or the amount where the spray is going to go. So it's a really simple concept, but it's really difficult to achieve. And so I'm going to show you how each one of these sprayers that we went through, how they performed, and where the deposition was and how it might relate to air. So I don't need you to read all the numbers on the side. This is like a really great graph because it shows you trends on all of these. This is the pack blast. And at the top of all of these slides, at the very top is the canopy deposition. The next slide down is your aerial drift, and your bottom slide is your ground drift. And so at the very top, under canopy deposition, on the left of the gold bar is all the canopy zones that are at the bottom of the canopy. So you're looking at zones that go across the bottom of your blueberry bush. The one to the right of the gold bar that says top, those are the 3 zones that go across the top of your blueberry bush. So it'd be left, middle, right of the top. So what you can see with the pack blast, and we optimized it, we looked at proper deposition, we did our very best, we put up water sensitive paper ahead of time, but the way that axial fan
sprayer occurs, we consistently got more deposition in the bottom zones of the canopy than the top zones of the canopy. If you look at aerial drift, in general with the pack blast sprayer, if you look at row 1, which is your second graph in row 1, you get more deposition closer to the row. So this is 1 row over. You get the most drift in the air 1 row from the sprayer. That's good. Through the years, it's decreased as consistently between the second row and the third row. So that's good. Most of your drift stays within 1 row of your field. If you look at ground deposition, it's the same thing with the pack blast because a lot of it is captured in the canopy. 1 row over on the ground is where a lot of that spray goes, which makes sense because if you hit the majority of the bottom of the canopy, the nozzles are putting out a lot more down there, and you're going to end up with ground deposition there, 1 row over, unless 2 and 3 rows over. So now let's look at the Canon sprayer. So in the Canon sprayer, same concept. The canopy is at the top, then the middle is aerial drift, and bottom is ground drift. So the Canon sprayer, remember, is meant to go around your block and shoot sheer all the way across the top of your canopy and then sort of deposit down. It works on a gravity effect. I'm going to spray as far as I can, and then what goes up must come down is what that concept is. So the canopy obviously then has way more deposition at the top and a lot less at the bottom because that's the first place it hits. The aerial drift generally has less deposition further from the sprayer, but if you looked close at those bars, there's often no significant difference between the first row, second row, third row. So what that means is that this sprayer is sort of working the way it's supposed to. It's just that it's blowing all the way across. You're still getting stuff blowing across even 3 rows over. Quite a bit, actually. If you look at ground deposition, it's the same, that you have more 1 row over, but you also get a lot of deposition in the middle of your rows that aren't doing you any good on the canopy. Okay, so now we look at electrostatic. So the canopy, if you look at that, it's the most even distribution through the canopy. So if you look between the bottom and the top, there's more similar amounts. The bar graphs are more similarly aligned. The aerial drift, it's even low depositions 1 through 3 from the sprayer, but it's a similar amount, nanograms per centimeter, so it's the same amount as the pack blast. So it's more evenly distributed. It drifts across all 3 rows, but it isn't like it's a huge amount of drift. It's the same amount as a pack blast, but it's a whole lot less than the Canon sprayer, 1, 2, and 3 rows over. And ground deposition again is similar, or is low in the second and third row from the spray row, but higher in the first row. Okay, so now this is what you can do for your sprayers. So the summary of that was, of those last 3 graphs, is that the sprayers are working how we would intuitively think about them. You know, if you're intending them to go over the top, you get more deposition in the top. If you are able as a tower sprayer, like the On Target is set up where the nozzles go up and down and spray horizontally into the canopy, you get more even distribution between the top and the bottom. But there are still things. You don't have to run out and buy a new sprayer, because there are still things that you can do to adjust your sprayers to make them have greater deposition. This is an example of an extension demonstration that we did in grapes. So those little yellow cards are water sensitive paper. And if you don't have any, you should pick them up, because they're yellow when they start, and then when water hits them, they turn blue. So it's a really great way to look at where canopy spray is going. So what we did for an air blast at the top, and we had this air blast in a grape canopy at full throttle, opened up, and we had all blue, meaning all the spray went towards the top part of the canopy. And we didn't like it. It wasn't even distribution. What we did is that GUTD is we geared up and throttled down, which led us to the bottom picture where we had more even distribution from all the way on the left, the top square down to the bottom. All that gear up, throttle down does is it reduces the rotation of your fan. So you're gonna gear up to a higher gear. You're gonna throttle down. So you gear up so you can go the same speed. You throttle down so that the PTO spins at a slower rotation, which means that your fan spins at a slower rotation, and you have more properly matched the volume of the air coming out of the sprayer with the volume of your canopy. It also happens to save you money on gas. So if you have a pack blast or an air blast that you're using in blueberries, looking at it with water sensitive paper, gearing up, throttle down is a great solution. If you have an on target, any other air shear sprayer, a Canon, you can never gear up and throttle down, because that technology is meant so that the droplets are formed when you have high pressure air running through the sprayer, and it will shear the liquid to create lots of fine droplets. Okay, last one. Let's look at weather, right? So temperature and humidity have a drastic effect on droplet size, coverage, drift, and control. And I'm gonna try and convince you of this, because if you have one of these sprayers, you're gonna have to think about how to operate them differently in different conditions. So we have 2 slides left. So temperature and drift in real life. And we didn't have in our blueberry study more extreme temperatures, and we were on the west side, so the humidity was a little bit higher. So this graph I'm showing you here with the, under the big word temperature comes from almost the exact same study except done in grapes and in eastern Washington. So very often we set a temperature threshold, and on labels it can sometimes be 85 degrees is when you should stop. 85 degrees Fahrenheit is when you should stop spraying. We performed these trials, and the light blue line is the early season trial, and it was at a lower temperature. The dark blue line is the late season trial, and it was hotter and it was drier. So lower humidity, higher temperature. So I want you to look, this is the drift, 1, 2, and 3 rows over. And in the early season, you had very little drift. It was all in 1 row because you were lower temperatures, and we were still lower temperatures, higher humidity. Late season, we went from drift being much higher, 2 and 3 rows over. And the only difference was a matter of from 70 to 84 degrees Fahrenheit and slightly higher humidity. So that temperature can really decrease the droplet sizes before it even reaches the canopy. So now you have to deal with how are you going to use these sprayers properly. So the air blast, if you were spraying the majority of the time in hotter conditions, then you can select a nozzle with larger droplets. I showed you those pictures. The on target, the Canon, any other air shear sprayer, you can only change your temperature threshold. Because you're already spraying very fine to fine droplets, you want to be really especially careful to be spraying at lower temperatures, below 85 degrees, so that you are not evaporating the droplets before they even hit your canopy. Okay, so then the last thing that I want to show you is that very often we get very warm. Then it starts to grow. Things start to grow really fast. We start to go through spray intervals. We just had our last talk about botrytis or powdery mildew. And are you keeping up with your intervals, and how many machines do you need? So there was a great study that was done on, it's a white paper that was done on how can we optimize, or the cost savings if we change a spray practice, how many dollars per acre can we save? And the study was done in grapes, but I think it holds true in blueberries and tree fruit. I've shown that to both of those groups. And when it goes down, if you change the top row from 1 to 2 rows being sprayed at any one pass, you can save the most amount of money. Decreasing your spray volume from 80 to 40 gallons per acre would save you the least amount of money. So when you're selecting a machine, if you have something that is like a pack blast, it's hard because that machine will never be able to go over multiple rows at a time, right? But an on target, we have a 5-row on target sprayer here in Eastern Washington. So it can go over multiple rows at the same time. So while it has some negatives that you need to be more careful about the droplet size and the temperature and the weather conditions, it has some real pros as well because you could go over multiple rows. The same would be true with the Canon sprayer. The Canon sprayer, while it had a lot of drift, it can spray multiple rows at the same time. The greatest concern by us as entomologists and Vaughn is that if the majority of your spray is at the top of the canopy, we're worried about SWD in the middle and bottom of your canopy. So you want to make sure that you're getting, when you adjust it, there's multiple heads on it, that you are still getting good coverage in the center and bottom parts of the canopy where SWD can hang out, because it's a little bit less hot down there in the center of your canopy. Okay, so with that, we are at the very end of the day. Chris, I don't know if you can do questions or not, or you can text them.
Are you stretching, Chad, or do you have a question? Any questions for Gwen? Gwen, can you hear me?
I can hear you.
Okay, we do not have any questions here. Do you have any at your site that you want to handle?
Guys, no, they're good.
Thank you so much, Gwen. That was great. Let's give Gwen a round of
Sound
applause.
got better.
Yeah, it figured itself out. It actually works great. So that concludes. Pesticide credits will be over on the left-hand side of the room. That concludes our like educational content for the day. There's a social hour I would suggest everyone go to. It starts right now. Really good food. Get a drink, hang out, and talk with everyone. And we'll start again tomorrow at 8 in the morning with the Washington Blueberry Commission. Thank you.
Okay, you want pesticide credits?